let's take a look at Newton's second law. Now this is stating that force is equal to mass times acceleration. So what is acceleration? Well, acceleration is the change in velocity over the change in time. Now time in physics, we measure in seconds. And velocity measures the speed of the object, but it's also dependent on direction. So if an object, let's say a ball, goes one direction, and there's a ball going in opposing direction as the other one, you would say that this has a negative magnitude of velocity, and this one would have a positive magnitude of velocity within this system. Now let's look at mass. Mass, which is measured in kilograms, right? Let's say if I have an object here, overcoming inertia, right? That will be able to determine how much the mass of an object, which is basically the matter of the object, how much the object is taking space, the amount of force that it'll take to overcome the withstanding of the object, not by it not moving anywhere, would be able to determine whether or not inertia has been overcome by the force, which is the subject here. Now, the cause of force, now the cause of acceleration is the force. And here's why. When I rearrange this algebraically, right, divide m on both sides of the formula, we get F over m, force over mass, equals acceleration, indicating that A is directly proportional to F. Acceleration is directly proportional to force. So that means when force is increased, the acceleration of an object is increased. And depending on the mass, this will determine how impactful the force is to cause the acceleration or speeding up of an object. Now if you rearrange this formula again, right, let's take this formula and let's find mass with this one, right? And let's describe mass with this. It's here. So as you can see here, as we rearrange Newton's second law formula, we get m, which is mass, is equal to force divided by acceleration. This is because when mass, the higher the mass is, that force that the object has, that will basically back that up, is caused by the mass of the object, which basically makes the object harder for it to move, or for it the force to be overcome. Now you can also see here that m is inversely proportional to a. The more the mass, the lesser acceleration. And this is because when the force, or actually when the mass or the force is powerful enough, the acceleration would be affected by that inversely, because the mass determines how much the object will be pushed depending on the amount of force that is applied to it, or pulled, depending on how much force is applied to the object with enough mass.